we'll give it a shot. Just as a reminder, the general form of this command for the norm distribution is going to be equals norm distribution of x, mu, sigma, and true. So x is the value on the x-axis. So in these first couple examples, it was 95 and 88. Mu is the mean. It's your population mean. What's sigma?
The standard deviation.
Good, the standard deviation. And for purposes of this class, this is always going to be set to true. And that'll give you the area in the left tail. So we got the area in the left tail in that previous one, but since we wanted the area in the right tail, what we had to do was we had to take the whole area, which is 1, and subtract off that little piece, which is what we did here. Based on this example, we need to do a little bit more thinking and come up with what are we going to do if we have to try and find the area between two values. Now, how are we going to handle this one? So I want... Yes, exactly. So we're going to find the area to the left of 110 and subtract off the area to the left of 85. So again, we need to subtract off a little bit of area here. Now you can do this in 1 or 2 steps. So for me, I'll do it in 1 step. I'll just put it all in one command. What you can't do is you can't subtract 110 minus 85 and then plug that number into your norm distribution. You have to do it like Nicholas described, which would be subtract those two values independently. So norm distribution of 110, 100, 15, and true minus norm distribution of 85, 100, 15, and true. So we're finding the area to the left of 110, subtracting off the area to the left of 85, and you should get something a little bit less than 59%. Let's take a look at that on Google Sheets. So that would equal norm distribution 100, no, not 100, 110, 100, let's give myself 100, 15, true, minus norm distribution, this time 85, comma 100, comma 15, comma true. So it should look like that. You should get about 58.889%, or not 889%, but just 50.5889 when you round it off to the nearest 10,000. So there's that command. Let's see the number. There you go. So 3 down, 1 to go. The last one's up to you. Before we actually do the last one, let me ask a question that I've asked a couple times here now. Am I going to expect an area greater than 1/2 or less than 1/2 for this one? What do you think? Yeah. All of this is to the right of 100, and you don't have the full area to the right of 100, so you're probably going to expect something less than 1/2 when we do this one. In fact, it's not a probably, it is a certainty. So go ahead and give yourself a chance at that one. If you're watching this later, maybe pause the video and see if you can't get the same answer that I get before I get it. You can unpause when you see this moved. So there's my artificial pause button. All right. Give that a little try. or a little bit less than 1/2? Good. All right, nice. So a lot like the last one, we're going to take the area to the left of 124, subtract the area to the left of 122, and let's see what that one's going to look like. I need another color pen here. So we'll do that one up here. That's going to equal norm distribution of 124, 100, 15, and then true, minus norm distribution of 102, 100, 15, and true again. Keep on forgetting to leave myself enough room to write true there. So that calculation on our Google Sheets gives us about 30, what's wrong there? 124.
335 to 102.
Yeah, there we go, 102. There we go. Well done, thank you. So 39.21%, or you can just read it as 0.3921. I don't have much preference for percent versus decimal for these things, but there you go. 1, 2, 3, and let's see, where am I missing one? Oh, I don't think I wrote down the first one. First one should have been 0.39 or 3694. So there we go. Not bad, not bad. But that's going in one direction. Question, Ian?
For the third example, we found the area of the middle shaded
Oh.
part, right? The 0.588.
Yeah, no, that's. Oh, okay, that's this one here. What was this one? This one. No, that's this one here, right? There we go. That was our 0.3694. Yeah, that one makes more sense. And here's our 0.589 was that middle one. So 1, 2, 3, 4. Okay. Let's change things up a little bit. Now we can change things up a little bit if we're starting out with an area and we want to find this value here. The norm inverse command works by taking this area in the left tail, and I can't emphasize enough that it has to be the area in the left tail as an input, along with the mean and standard deviation. If you input that, it'll tell you where you at on the x-axis. Okay, let's check those out. We're going to stick with the same distribution with a mean of 100 and a standard deviation of 15, so the distribution of intelligence. We want to find the z-score that corresponds to this shaded area. Now that shaded area is to the right here. It's telling us we got 15.87% of the area in the right tail. And that's great. So if you're starting out with an area and you want to find the score on the x-axis, then you're going to be using the norm inverse command. Let me remind you and anyone else watching this that this is distributed normally with a mean of 100 and a standard deviation of 15. Okay, so you're looking at that and like, all right, we need this x value, I got that area. And yeah, you got to be a little bit careful. What command am I going to use? Am I going to use norm distribution or norm inverse?
Norm inverse.
norm inverse. Norm inverse. Now here comes another question. What am I going to put in this norm inverse? Go ahead.
I have no idea.
Don't you have to,
Mm.
don't you have to subtract?
1 minus that number?
Ah, well, let's think. Tell you what, let's do a little thought experiment. What if we were to think about what value this would be? What number should this be?
100.
That should be 100. Do we expect our number to be more than 100 or less than 100 when we calculate it? Has to be more. Just look at the graph, right? This number has to be to the right of this because it's to the right of our 50th percentile. What if I accidentally typed in norm inverse of 0.1587? Let's take a look at that. So this is example B. And I'll just go up to here, this column. Example B equals norm inverse of 0.1587, comma 100, comma 15. How do I know I got this one just wrong?
It's less than 100.
Yeah, it's less than 100. Thank you. Just so it's something wrong. And the something wrong is that the way Google Sheets works is it works with the area in the left tail. So how much area is in the left tail? Or how can I find out the area right here? Yeah, so you're going to take 1 minus 0.1587. That's going to be what, 0.8413? And that's what you're going to plug in, 0.8413, comma 100, comma 15. Mean standard deviation. At the very least, it should give you something above 100. Let's see that that happens. So this is still example B. Actually, what I'm going to do, I'm going to copy this. I'm just going to make the one change. I'm going to make that 0.8417 or 13. So about 115. Perfect. So basically you're about 1 standard deviation above the mean at that point. So equals 114, about, we'll call it 115.00. Round it off to the nearest 100th place. I'll put a little dot here meaning approximate. See the command?
Yeah.
It's this one right here.
NA.
What's that?
It's coming up NA for me.
So if it's coming up NA, sometimes what happens is that there's a hidden character in your calculation someplace that you're not aware of. What I'll do sometimes if it's coming up NA is I'll just wipe out the whole thing and start all over again. Or sometimes I'll even go to a brand new cell because there's just some hidden character, something wrong with that cell that is just not liking me. So norm inverse of 0.8413, comma 100, comma 15.
So for a norm inverse, we don't have to put the true.
Yeah, for norm inverse, you don't have to put the true. Oh, you got norms inverse.
What?
It looks like there's an S up there when you type in.
Norm has its own inverse?
It's norm inverse. It looked like you had an S in there. Norms inverse. Yeah, norm. Oh, that's a different command altogether. No. Norm, NORM, INV. Right there. That's the first one. Yeah. You had an S in there for some reason. I'm not sure where it came from. Let me know if that one works. I got a follow-up question to you. What percentile is 115. Is it the 84.13 percentile? Let's round it off. Is it the 84th percentile or closer to the 16th percentile? Which one? You guys sound pretty certain. Are you that certain? Or are you good guesses? Good guessers. All right, yeah, it is 84. This separates the bottom 84% from the top 16%. So this is the 84.13 percentile. So just a little bit of a reminder there because you got a test on this stuff coming up. So it doesn't hurt to look at that. Did that one come up for you, Nicholas? Okay, good. Let's move down to example C. Let's find the average monthly temperature for, well, we already did that. Let me give you the distribution here. The distribution is that it's normally distributed with a mean of about 22.73. And let's round the standard deviation off to a nice friendly 5. Assuming that it's a normal distribution, what's the 99th percentile? What's the third quartile? So two different calculations there. For the 99th percentile, well, kind of hard to squeeze that in here. But where's, let's see. Let's start with this. X is distributed normally with a mean of 22.73 and a standard deviation of 5. 5. What number is this going to be down here?
Oh no, 22.73.
Yeah, thanks, Oz. 22.73. Standard deviation of 5. Okay, standard deviation of 5. That's great. We'll use that in our calculations, but not here directly. I want to find the 99th percentile. Is that going to be way out here in the left tail or way up here in the right tail? The right tail. It's higher than 99% of your data, so it's going to be this point way out here. All right, and I can't really draw it too accurately. It's going to be about here. 1% of the area is going to be here, or 0.01. But that's not what I want to type into Google Sheets. Why not? What do I have to type in? If I want to find what this value is on the x-axis that separates the bottom 99% from the top 1%, why don't I want to type in 0.01? We need the area in the left tail. So what is that area in the left tail? How much of the area is here if 1% is in the right tail? 99, which as a decimal is 0.99. So for the first part of this, the 99th percentile, you're going to type in equals norm inverse of 0.99, comma 22.73, comma 5. You should get something between 34 and 35 degrees. Bridget, when you're ready, what'd you get there? 34 point. All right, yeah, 0.362. Okay. Bridget, did you get the same thing?
Yeah.
Okay, thank you, ladies. What about the third quartile? Let's do that one, third quartile. So going back a little bit to our sections on positions, relative to positions. Third quartile. What does that mean for our data? What's the third quartile all about? What does it separate?
The upper half and the lower half?
That would be the median or the 50th percentile.
The bottom 3/3 and the top third? Or the bottom 3/4 and the top quarter?
There you go. The bottom 3/4 and the top 1/4. What percentile does that turn into? If you're talking about the 70, or excuse me, I guess I'm trying to get away there. Yeah, what percentile is the 75th percentile? Anyone, first one. All right, so it's going to be the 75th percentile. So we're going to do essentially the same command. Understanding the third quartile is the 75th percentile. So it's going to equal norm inverse of 0.75 and 22.73 and 5. And that'll equal, let's see, am I expecting a number bigger than 22.73 or less than 22.73? Bigger. It has to be. This is your median, your 50th percentile. The 75th percentile has to be bigger than that. So 26.102. Is that what you guys are getting? All right. Looking good there. All right. Comments on example C here? Yes. Let me just double check here. I didn't actually do that calculation out, so. So equals norm inverse. What? Okay. Well, let's just check it anyway. 0.75, comma 22.73, comma 5, and bang. But I appreciate you checking me. Thank you so much. All right. Let's move on to the next page and give you a chance to find out something about yourself. So according to Google, according to Google, men have heights which are distributed like this. X, which is distributed normally with a mean of 70 and a standard deviation of 3. Okay. Women. Your heights are distributed normally with a mean of 64.5 and a standard deviation of 2.5. Now, if I was to lay these graphs side by side, which one of them would be more spread out? Heights of men or the heights of women? Men. Men have a standard deviation of 3, women have a standard deviation of 2.5. What I want you to do is I want you to figure out what percentile of height you're in. Now, just for the sake of being helpful, 60 inches is 5 feet. 72 inches is 6 feet. So if you're 6 foot, if you're 5 foot 7 inches tall, it'd be 60 plus 7, it'd be 67 inches tall. Figure out your height, and then in inches, of course, and then try and figure out what percentile of height you're in. So I'll be doing that for myself, which is going to be here. X is distributed normally with a mean of 70, a standard deviation of 3. You might also want to do yourself a little bit of a favor. What's this line going to get labeled with? The mean. Thank you. Perfect. So that's going to be a 70. So that if you're above a 70, you're going to be above the which percentile? Above the 50th. If you're below 70, you're going to be below the 50th. But find out what percentile your height is in. So again, I'll kind of walk around and try and taunt you, help you. computer? It's like, wow, I like it, just like you. But he didn't have to. He knew the answer. Okay. There's a sheet that you missed when I started this.
I'm sorry, I'm trying to pull up the pencil to fix.
Appreciate that, thank you. Okay. Okay. Well, yeah, because you're starting out with this and you want the area, right? So. What are you working on? Okay, yeah. Yeah. That's a good question. What's your height in inches? Okay. So the first thing we have to decide is norm inverse or norm distribution.
Well, he's saying,
I don't know.
and she's saying it's norm inverse.
Okay.
Okay, so I have a question on if I did this correctly. I did norm inverse because I knew that my height would be less than, was that right? So it would be to the left.
Well, let's think about what norm inverse and norm distribution do. And I'm going to talk about that up here because you're not the only one getting confused.
Okay.
All right.
And then it's how we.
Okay, so probably not a bad time to review the difference between norm inverse and norm distribution, right? Because I imagine that you got an error when you typed in that command, right? Yeah. All right. So what does norm distribution do? It starts out with an x value and returns an area. So this is what you input right here. You start out with an x, you input that there, and then you end up with the area in the left tail. That's going to be your output. Norm inverse starts out with an area, so it starts out with this. That's where you input, and then it outputs this value on the x-axis. So which way are we going? Well, do we know the area, or do we know the x value, or do we know the area? What are we inputting into our equation or into our formula?
The X value?
The x value. So that would be norm distribution. What you're going to do is you're going to start out with the x value, put it in with this command, and then it's going to tell you the area. Does that make sense, which one we're doing and why? We know how high we are, we just don't know what percentile we're at. So you're putting in this value on the x-axis and trying to find the area. We don't know the area. We can't put in a number. We need to find that number from our norm distribution. So let's see what it will look like for me personally. Let's see. So I would type in equals norm distribution, and then my height, which is 73, mean of 70, standard deviation of 3, and then true. And it should tell me that I'm in the 84th percentile of height. So that's not shocking. 73 is over here someplace. I should be more or past the 50th percentile. I am. That's good. I don't know. A couple of you, I feel bad because Your percentile was a little bit lower than you might have wanted or wanted to know. Cosmo?
I'd like to point out, mine is technically not significantly low according to your rules.
You're right. You're right. Cosmo is not technically significantly low. Not by much, but you're still above significantly low. Good job. Good job. But he's a fast swimmer, so it makes up for it. All right. Anything else on this one? Are you able to get yours? Yes.
So, like, if you're a female, would it be like your height, then 60, then 2.5? Then
Exactly. Do you want me to do yours up here? Just for.
if that's okay.
Sure. So go ahead. It's going to equal norm distribution. What's your height? 63? And then 64.5. Now, because this number is less than this one, you're going to be less than the 50th percentile. Because you're to the left. That's given up here. Those are numbers that I just got off of Google. All right? So I Googled those. I think I mentioned it right here at the start of the problem, that when you go to Google, it says this information for these heights. So that's the mean. Here's the standard deviation, 2.5, and then true. So because you're, like I said, to the left of the mean, you're going to be 0.27 something? All right. Yeah. Yeah. Personal experience there, Matilda. Equals norm distribution, or norm distribution of 63, 64.5, 2.5, true. So there you go. 27 point. Yeah, I know. I'm feeling bad that you have this new awareness of yourself and not everyone's really happy. On the extreme side of things,
So,
yeah, go ahead.
would she be in the 27th percentile?
So yeah, she's taller than 27% of ladies and not as tall as 73% of ladies.
Okay.
So about the first quartile is where she's at. On the other extreme of things, a colleague of mine that teaches ESL, she is 75 inches tall, which is just, I mean, there's not too many women in this world that I look up to in a literal sense. You know, figuratively, yes, but literally, no. Look at that, 99.9986 percentile. Wow, that's just, yeah, that's just really wickedly tall. All right, question? How did you were pretty tall.
Yeah.
What percentile did you end up in?
0.9192.
9192? All right, that's good.
So
That's
that's
good.
the 91st percentile.
91st percentile, so taller than 91% of women.
Is lower than 0.02.
0.02 percentile? All right, so that seems like, anyone got that one beat in terms of an extreme? Anyone in the 98th percentile, up on the top end? 99th percentile? How tall are you? 6'5"? 99th percentile, way to go.
5'4", probably shorter.
Yeah.
Since I last measured.
Well, if you're going to measure yourself in the morning, because as the day goes on, you shrink. Yeah. Yes. Yeah, your spine compresses a little bit. So, all right. Pretty fun, I hope. Yes. You know, a little personal information. Maybe a few of you are like, I could have done without knowing that. All right. Let's keep going. I want to do a few more. I want you comfortable with this stuff before we finish this up. Notice the stuff we're doing now is really a repeat of what we did on Tuesday. It's just that on Tuesday our numbers were all 0 and 1 for the mean and standard deviation. Now we're expanding things, and the mean can be anything, the standard deviation can be anything that's a positive number.
I have a question.
Yes?
So if it was a test and we didn't have the mean or standard deviation, we would use 0 and 1?
The only time you'd use 0 and 1 is if you knew it was the standard normal curve. That's the only time you'd use 0 and 1. You would have to be given the mean and standard deviation to do these problems in general. Make sure that on test day you have a laptop with you. And let's see. There's one other thing I wanted to say here. There was somebody in my morning class, and maybe there's somebody in this class too, it was exactly 70 inches tall. If you're exactly 70 inches tall, do you really have to do norm distribution to find out your percentile height? No. What would it be? 50th percentile. Yeah. And if you actually did do this calculation, it'll tell you 0.5 exactly. So you don't really have to do it though on that particular instance. Let's move on to example E. Engineers want to design seats in commercial aircraft so that they are wide enough to fit 99% of all males. Accommodating 100% would be too expensive. Men have hip breadths that are normally distributed with a mean of 14.6 and a standard deviation of 0.9. Let me start by writing that down here. I like taking care of that. Mean of 14.6, standard deviation of 0.9. We want to find the 99th percentile. Now, in this problem, I was pretty generous. I reminded you that this separates the bottom 99% from the top 1%, but come time for the test a week from now, I expect you to know really what the 99th percentile means. Let's see here. Bridget, let's label this to start with. What should I label this with? 14.6. Do that for yourself when you do these problems. In fact, it might be part of the instructions to label your graph, and I'll give points if I actually say label your graph. But part of that is so that we know, what to expect and if our answer looks reasonable or not. Thank you. Let's see, Jackson. Where do I expect the 99th percentile, in the right tail or the left tail? Yeah, it's going to be someplace out here, far in the right tail. Thank you. So when we calculate our value, Sam, for the 99th percentile, do we expect something greater than 14.6 or less than 14.6? Yeah, it has to be to the right. If you're talking about 1% of the area here, 1%, or 99% here, well, that's past 50%, so it has to be in the right tail. Am I going to use norm distribution or norm inverse? Ian by the window? Norm inverse. Well done. And Ian in back. Norm inverse of what? I'll throw in the mean and standard deviation here for you, 14.6 and 0.9. But what should I put here? What number goes there? Tell you what, let's experiment with 0.01 and see what happens. So let's come up here. This is example E here. Example E equals norm inverse of 0.01, comma 14.6, comma 0.9. 12.506. So I want someone to be critical of our answer, not critical in a mean way, but critical of like, okay, I've said something's wrong. What's wrong with our answer? Why can't it be the right one? Yeah, it's smaller than you mean. It's in the left tail, not in the right tail. So what's the fix for that? How do I get something in the right tail? What do I have to put here? Point. Yeah, so you're going to take 1 minus 0.01 and get 0.99. That's going to put your area, figure out how much area is in the left tail, and that's what Google Sheets expects, is the area in the left tail. So let's go back and fix our command. You don't have to retype everything. Just go back here and replace the 0.01 with 0.99. And now at least we get an answer that makes sense, about 16.69. And if it matters to me how many significant digits that you give me, I'll tell you. I said round your answer to the nearest hundredth, thousandth, or 10,000th, whatever the case may be. There you go, about 16.69 inches. Are we okay with example E here? Evan?
I just want to get clarification on the question. So, find the hip breadth for men that separates 99%, 1%, and we found 16.69.
Correct.
That means if your hip is larger than 16.69, you're in the top 1%, and so this number is our separator.
Right.
That's what we were looking
That's
for.
exactly right.
Got it.
So this separates the top 1%. These are the people that won't fit in this seat from the 99% that will fit in that seat.
All right. Thank
All
you.
right, you're welcome. Just for kind of sake of completeness, and going back to Lizzie's question earlier, suppose that we had this number and we wanted to work it backwards. Let me just copy that. Let's see, I guess I'll have to do it this way. Let's do equals norm distribution of 16.693, 6937, I'll go one extra digit. And then I'll put in the same mean and standard deviation, 14.6 and 0.9, comma, true. What number do you think I'm going to get out of this? Approximately.
14.6.
Should be about 0.99, and that's what it is. Because these things do opposite things from one another. The first one starts out with the area, and it gives you a score, a number on the x-axis. Here you start out with your number on the x-axis, which was this one, and you end up with the area. In this case, the area in the left tail, about 0.99. I mean, it's very close, really close. Let's move down to example F. Now, the mean and standard deviation that we have here are a little bit different than what we used when we personalized this for you. This is coming from the problem itself, not necessarily from Google anymore. So they say that women's heights are normally distributed with a mean of 63.8 inches and a standard deviation of 2.2. So a little bit less in both regards than what Google was giving us. Google is giving us more variability and taller women. So if you didn't like your results from the first one, you can repeat your calculation down here. Maybe it'll be better, not sure. There's two parts to this. First of all is find the percentage of women meeting the height requirement, which is between 58 and 80 inches. 80 inches is just ridiculously high. There's no one that tall. All right, so let's make that, let's go 75 in honor of my colleague that teaches ESL here. So I want the number of women, the percentage of women that are this tall. I want you to think about this for a second. Finding this percentage, is that going to involve norm distribution or norm inverse? Think about it for a second before you shout the answer. Norm distribution or norm inverse? Which one are you using here? All right, we'll do it together. 1, 2, 3. Which one?
Norm distribution.
Oh, I heard a lot. I heard for a variety of voices, but mostly I heard norm distribution because you're starting out with things on the x-axis and then trying to find areas. So we want to try and find the height of women or the percentage of women between 58 and say 75 inches tall. Now you've got this middle value down here, which is 63.8. But we want to find the area between these. And finding an area involves your norm distribution. So how are we going to find this with norm distribution? What are we going to do? Yeah, you're going to subtract it. You're going to find the area to the left of 0.7 or of 75 minus the area to the left of 58. So you're going to subtract those two in order to find the area. So part A, let's see, do I have enough room here? Yeah, I think I can squeeze it in. A is going to equal norm distribution of 75, comma 63.8, comma 2.2, comma true, minus norm distribution of 58, comma 63.8, comma 2.2, comma true.
How do you know 58 was on that line?
It may or may not be. Doesn't matter to me. All I'm doing is I'm drawing a graph to kind of guide my intuition that I'm looking for stuff in between these, and so that's why I'm subtracting. Yeah, but I appreciate that. Yeah, I don't know that it's right here or not. In fact, it's probably not.
That you have that one directly on the line and the 75 off to the right.
Yeah.
Where those lines-
Yeah, nice observation there. I wasn't trying to be that precise. I just happened to use this one as is. So let's take a look at that one. Example F. Inches, not feet. Let's see, so equals norm distribution 75. Where was it? 63.8. And then true. Now I'm just going to help myself out a little bit here. I'm going to copy that command. Minus. And then the only thing I could do is edit this to put in a 58. So there's my command altogether. And about 95.58. That's interesting. 95.9958. So these are the women with heights between those two values. Are a lot of women getting excluded because they don't meet the height requirements? No. Less than 0.5%. 0.42% women wouldn't meet the height requirements. If you're going to recalibrate things so that the military says, all right, we're going to exclude the shortest 1% and the tallest 2%, what would be those new height requirements? So again, let me ask you, norm distribution or norm inverse? Now it's the inverse, because you're starting out with the area and you're trying to find the actual x value here. If you're trying to work with the shortest 1%, are you going to expect a value of heights less than 63.8 or greater than 63.8? Less than. So make sure you get that when you type in your command. Norm inverse. Shortest 1%, what number should I be putting into my norm inverse command? 0.01, yes. So 63.8 and 2.2. You don't need the true for the norm inverse command. That's kind of nice. That's only for the norm distribution command. And then for the upper end of things here, the other part is going to equal norm inverse of 0.99, 63.8, and 2.2. Oh, 98. Yeah, that's right. Top 2%, not top 1%. Thank you. So on this one, this end of things, about 58.68. Is that what you're getting here? And check yourself on the other one as well, please. You should get something about, around 6'8", or I mean 5'8". There. There. And let's see, I want one more. So let's just do that one, that last part together. So 68.318. Nice. Are you able to get that off of your Google Sheets? Doing okay on that one? All right. A lot of nods. Thank you so much. I think that's all I got to say for this section, other than the fact that you guys are lucky that you don't have to do this old school. Old school is a lot of work back when we had to do it with looking up values in tables. Basically, you would have to calculate something like this by using this formula times sigma. So mu is your mean, sigma is your standard deviation. Z sub alpha is a number you'd have to look up in the tables, but you have to use the tables in a backwards direction, which took a little bit of mental dexterity. Then you have to plug in this formula, grab this all out. It's a lot more user-friendly doing it with Google Sheets. I want you to know how to find these values, you know, using Google Sheets and what they mean. They separate the bottom 1% here, the top 2% up here. That's great. The actual nitty-gritty and being able to calculate that, well, you know, I'm happy enough that you can use Google Sheets on that. Any last-minute comments or questions before we wrap this one up? Okay.